Bismillahir Rahmanir Rahim. Alhamdulillahi Rabbil Alameen. Wa sallallahu wa sallama ala Sayyidina Muhammad wa ala alihi wa sahbihi ajma'in. So, as we read the books of the Mutakallimun, they talk about falsafa. And falsafa is the search to know about things through the human mind alone without recourse to revelation. And the falsafa, the part of falsafa that we are interested in is the falsafa about the universe. What is the contingent universe made of? What constitutes it? So when we read Taftazani, he has a model of the universe, and this model, it's based on a'rad and ajsam and jawahir, and he's talking about competing models such as the model of Ibn Sina and Aristotle, hylomorphism. We looked at these models. What is the universe made up of? So this diagram, I think, is taken from the 16th century. It's in Latin, and this for most of human history since the Greeks, people have believed that the heavens were made of celestial spheres. In Arabic, this is falak or aflak. So when you see the word falak or aflak in the books of the Mutakallimun and also often in the works of the Mufassirun, what they mean by falak is a sphere. And so they would observe the stars, and they saw that the stars, they move in the sky, but the relative distances of the stars to each other remains the same. So they appear to be moving together. So the dots in the sky, they all move together. And so it appears as though these dots are embedded in a sphere that's very far away, and it's that sphere that's moving. So historically, the problem was that this worked for the stars, but there were certain objects in the night sky that behaved differently, and these were the planets. And the word planet comes from the Greek word which means a wanderer, and the planets, they didn't quite fit the movement of everything else, because the planets, since they're closer to us, and we now know that the planets, they go around the sun, they move erratically. One night they're in one place, another night they'll be in another place, and their position relative to the stars in the sky is different. So what they took this model of concentric spheres, and they tried to construct, where these other spheres, and fit the planets into the picture, so that all of them, they rotate at different speeds relative to each other, and then you can predict where a particular star or a planet will be in the sky. This is a simplified presentation. This is what they used to believe, and they used to place the Earth at the center. And so this is called a geocentric model of the universe. Geocentric, geo refers to the planet Earth, and the Earth is at the center. So one of the most famous revolutions in Western science is the revolution that the Earth is not the center of the universe, but that the sun doesn't go around the Earth, but the Earth goes around the sun. So in a geocentric model, the sun is also going to be in one of these spheres, and the moon is also going to be on one of these spheres, because these are all celestial objects and they go around the Earth. So Copernicus, he's famous 16th, 17th century, for putting the sun at the center. And this is a heliocentric model of the universe. But he maintained this idea that there's celestial spheres. This remained. The idea of celestial spheres, and it's these spheres that rotate, remained for a long time. So what we want to understand is that when the Mutakallimun, they're talking about the heavens, and they're talking about the elements, and they're talking about the universe, it all fits within this falsafa. Falsafa means discovering things about it means anything, but we want to restrict it to the contingent universe, natural philosophy. So they discovering things about the physical universe based on the human mind alone. This is falsafa. We now have a new falsafa. Our falsafa now is our model. So that we believe, instead of a'rad and ajsam, we believe that everything is composed of atoms and subatomic particles, and the physical characteristics of everything, of all matter, can be explained by reducing them to the physical characteristics of atoms and molecules. And then in terms of the universe, we don't believe in these concentric circles anymore, these celestial spheres, but we now believe that the universe began to exist at a particular point in time, and the event that of its existence is called the Big Bang. A misleading term, because the physicists, they say that it wasn't big, but it was very small. So the idea behind the Big Bang theory is that all the matter in the universe was squeezed into a very tiny space, and it started expanding, and this expansion has continued down to, and it's still expanding. And so when you pack matter very closely together, then its temperature increases. The gas laws that we learn in physics and chemistry, its temperature increases. When they're further apart, then they cool down. So things are hotter when they're closer together. So if you take everything in the universe and you put it into a very small space, a point, then it gets very hot, and it expands, and as it expands, the matter becomes distributed over a wider and wider area or volume, and things begin to cool down, and as things begin to cool down, the first atoms form, and the simplest atom, hydrogen, is the first one to form. There'll be some helium as well, and things expand more, things cool down, and then the hydrogen, mainly hydrogen and helium, they start to come together. Because of the force of gravity. We put force in quotation marks, because we can speak about it in scientific terms, but we keep in mind that we don't believe in forces. A force is a quwwa, and everything it happens by the creative action of Allah subhanahu wa ta'ala. So, but because of the force of gravity, which is a description of how Allah subhanahu wa ta'ala regularly runs the universe, these atoms and molecules, they came together, or they were brought together, and they large volumes of them, and stars were made, and then you have nuclear fusion at the center of the stars, and in this fusion process, and then it explodes. Stars explode. There's a evolution of the way that a star it uses up the elements, and it has an explosion called supernova, and in that explosion, most of the elements, apart from hydrogen and helium, they're formed, and they're scattered all over the universe, and then they come back together through the force of gravity again, and the process cycle continues while the universe is expanding. So this is the current falsafa. So we're going to call this falsafa. Modern science is the new falsafa. So just as the ulama of the past, they engaged with the falsafa of their times in order to do ithbat of their aqidah, we need to do the same. And so we'll try to begin doing that as we study our Sharh al-Aqaid. So the important thing here is that the expansion of the universe is the Big Bang theory, the Big Bang model. It's a very revolutionary discovery in science, because if you go back in time, if the universe is expanding and you turn the clock backwards, then it becomes very, very small. And what the scientists, they describe that initial moment as a singularity. A singularity is, so a mathematical singularity, you have here, there's a graph here, the graph 1 over x, it looks something like this. So 1 over x, like this, if you, they have the x-axis and the y-axis. X-axis is the horizontal axis, y-axis is the vertical axis. As x becomes closer and closer to 0, y becomes large, and at x equals 0, the function 1 over x is undefined. This is called a singularity. So a singularity is where your mathematical model breaks down and things just become, they go out of control, and you can't describe that anymore using mathematics. And mathematics is the language of modern science. Modern science is written in the language of mathematics, particularly physics. And so it's the way, so we use the language of mathematics to describe everything that happens in the universe, the way the universe works, and we have a mathematical model for the way that the universe has evolved since its beginning, and physicists have gone further and further back in time, and they try to go, and I think they've gone back to 1 over 10 to the power 35 seconds or something like that, and then things they don't work, and so they continue to research, and they go closer and closer to the Big Bang, what would have happened based on our math, but they can't actually get to time 0, because at time 0 you have a singularity. So so this lesson is going to be an overview of so I have here written old falsafa, but it's just saying new falsafa at the top of the slide. So this lesson is going to be an overview of this new falsafa. Some of you will be familiar with this, and some of you will need to review your science education. If you have a high school science education, you can understand everything that I'm going to be talking about in this lesson. You don't need more than that. If you've studied more, then you will understand more. But if you're not a science wasn't your thing in high school, or you never did science, then you'll be at a disadvantage. And so what you should do is, and the purpose of this lesson is that if you want to do kalam in an advanced way, now you have to learn science. Just as in the time of Taftazani, if you wanted to do kalam in an advanced way, you had to learn falsafa, and you see it throughout his book. So it's not possible to do kalam today without having a good understanding of science, because these are the people who you're talking to. So I'm going to, as I'm going through this lesson, I'm going to mention various topics, explain them. You might understand some, might not understand some, take notes, but you can use this for your further research, further education, and if you have questions, I'll be happy to ask. I'll be happy to answer to the best of my ability. So that's the purpose of this lesson. So it's an overview of the new falsafa, and we are particularly as relates to the field of cosmology. Cosmology is the study of the universe as a whole, and because this is going to be very closely related to the Kalam argument for the existence of God, as we'll see in the next lesson. So the Big Bang theory is based on something that we call hads. Hads is it's a kind of ilm daruri, a non-inferential knowledge. So our ulama, they divided knowledge into inferential, non-inferential. We did this as part of our Sharh al-Aqaid earlier. Also in our studies in logic, we do this. And non-inferential knowledge, there are 6 kinds of propositions. One of these propositions is hads, hadsiyat. Hads is when you, now this is called inference to the best explanation, IBE. And it's studied in detail. There's lots of philosophers, they've written about it. And scientific reasoning is based on IBE, inference to the best explanation. And inference to the best explanation, we would call it hads. And the philosophical discussions around it now are far more advanced than anything that our ulama they talked about. So it's something that we need to be familiar with. if we have an advanced course in theology and philosophy, this would be a topic that we would study, because this is what scientific reasoning is based on. But here's a link. So how does HUDS work? The way that HUDS work is you see a number of different things. So you see, for example, you look at the moon and you look at the phases of the moon and you see how it changes, and you look at the sun and you notice that the phases of the moon they're circular. It's like a circular shadow, and you gather other data, and suddenly you have a realization. You have a realization that if the phases of the moon were due to the shadow of the earth on the moon, and the moon reflected the light of the sun, then it would all make sense. It would all fit together. This is HUDS. And then immediately you come to have a belief that this is how the phases of the moon come about. This is HUDS. And so now so you look at all of these data points, it fits. This is what it is. And how exactly does this knowledge come about? It's not a syllogism. It's not an inference. But you do make an argument because you gather various data points. And how exactly does this work? Our ulama didn't go into it in detail. But many people have written about this, and the philosophy of science talks about this as well. We don't agree with everything that's said, but it's good to get an idea of what's being said. And if you have a training in mantiq and kalam, then you can navigate it. You can say that, okay, this is right, this is wrong, but we need so for now you can just get a general familiarity, and then you need to be walked through the various aspects of it. But for now, the Big Bang theory is based on HUDS. And what's HUDS? HUDS is that there's many data points, and if the Big Bang theory were to be true, then everything would make sense. And that's how we know that the Big Bang happened, or we believe that the Big Bang happened. It's important to note that our ulama have said that HUDS can give you certainty. HUDS can give you probabilistic knowledge, it can give you dhann, it can also give you yaqeen. Does it give dhann? Does it give yaqeen? In order to make that judgment, you have to have specialist knowledge. It appears that it gives something very close to yaqeen at the current moment, based on what I've seen and I've read. But the exact level of it, somebody who has a better knowledge of the new falsafa than I do would be able to give a better answer to that question. But they would have to have some training in Islamic epistemology before they could give a reliable answer. So this HUDS, I'll give you, what I'll do is I'll walk you through in this lesson through a number of data points. So this is the first data point that they normally mention, which is Olbers' paradox. Olbers' paradox, it's from Wilhelm Olbers, a German scientist or philosopher, 1600s. And he said that so there's, at this point, what do they believe? Many physicists, many scientists, they believed that the universe everybody believed that the universe is static. Static means unchanging. So even the Muslims, they believe that the universe is static. It means it doesn't change. You have these celestial spheres, they rotate, but this is how it is. And nobody believed that the universe was expanding and evolving, that it was different in the past than it is now, and that it will be different in the future. Nobody believed this. And so I don't know, there's probably someone who believed it in human history, but we don't know of these people, and they were definitely rare. And for most of human history, we've believed that the universe is a static universe. And this is one big difference between the old falsafa and the new falsafa. We no longer believe in a static universe. The other aspect of it is that many people in old falsafa, they believed, not all, but many of them, they said that the universe, it's infinite in size. It has no end. It just goes on and on and on and on, and it's so large, and it doesn't have any end. So and it doesn't have a beginning. And the falasifa, the old falasifa, certainly believe that. And if you believe in a static universe, then you have it's still an incorrect conclusion. You can't conclude from the fact that the universe is static that it has existed for forever, because it's an incoherent conclusion. However, you have more of a reason to believe. You have a shubha, you have a false, that if it isn't changing, then you say, okay, it's probably never changed. It's always been like this, and so it's existed for an infinite period of time. So Olber, and there's other people who said this before. They said that, well, if the universe has existed for an infinite period of time, and there's stars everywhere, and there are infinite stars, even and there's an infinite number of stars, then this night sky should not appear to be dark, because if you take a light and you shine it, it spreads around you and everything becomes light. So if there's an infinite number of stars, then everywhere you look, you should see there should be a star in your line of sight. The light from the star should have had time to disperse all over the universe. The night sky should not be dark, it should be bright. And so this was a paradox. Nobody really knew how to answer it, but it suggests that either the universe is not static, or it's not infinite, or both. This is the first, and it remained, and the Big Bang model solves this paradox. The other paradox that has been around for a long time is that the universe is cooling down. Imam al-Ghazali mentioned this as well. He mentioned that things are cooling down, and if the universe had existed for an infinite period of time, there wouldn't be any, the sun would have burned out, and there wouldn't be any sun. So this is from the second law of thermodynamics, and this certainly we know is true, that if the universe had existed for an infinite period of time, then it would have reached steady state and maximal entropy, and there would be no stars to see. So the fact that you look up and you see stars, it means that they're an infinite period of time, which is an incoherent concept. It makes no sense, we'll see. But it means that an infinite period of time has not elapsed. You look up, you see a shining star, it means the universe has only existed for a finite period of time. It means that the universe had a beginning. The universe is expanding. This is in the 1920s. This is the revolutionary discovery. How was this discovery made? I'll just step back and walk you through how it was made. This is so on the left hand side you have the electromagnetic spectrum. So the light that we see is a small part. You see here that it's called the visible part of the electromagnetic spectrum. So the electromagnetic spectrum is you have electromagnetic waves, and these are oscillations and energy that is transmitted, and it can go through a vacuum, and it's a field, not a particle, although maybe it is a particle. Is light a wave or a particle? Sometimes it behaves like a wave, sometimes it behaves like a particle, but light is a small part of waves that have larger and smaller wavelengths. So a wave is a change, it's an oscillation. So change, it's a regular change, and so you have this thing called a wavelength, and which is how closely packed the energy in the wave is. So if the oscillations are very quick, then you have a high wave, you have a high frequency and a small wavelength. And if the oscillations are very far apart, then you have a large wavelength and a low frequency. So this spectrum shows you you have the electromagnetic waves. They can have a small wavelength, they can have a high wavelength, and it's a tiny part of the electromagnetic spectrum that is called the visible part of the electromagnetic spectrum. And it's really Allah subhanahu wa ta'ala, it's really amazing that that a lot of the evidence for the Big Bang, it comes about as a result of things that we can observe in the visible part of the electromagnetic spectrum. It's as though Allah subhanahu wa ta'ala made this for us to see. There's two verses here. These verses, the first verse is أَوَلَمْ يَرَ الَّذِينَ كَفَرُوا أَنَّ السَّمَاوَاتِ وَالْأَرْضَ كَانَتَا رَتْقًا فَفَتَقْنَاهُمَا وَجَعَلْنَا مِنَ الْمَاءِ كُلَّ شَيْءٍ حَيٍّ أَفَلَا يُؤْمِنُونَ. This verse has been interpreted in various ways. So classically, some of the mufassirun, they said that this refers to the samawat, and that the samawat on their own were ratq means to be closed, to be closed. So ratqa in books of fiqh, a woman who has something on her private part that prevents her husband from having relations with her, she's called a ratqa, and it has implications for the marriage contract. So, but ratq means to be closed. So this is saying that. So one of the ways in which this verse was classically interpreted is that the heavens were closed and the earth is closed, and then the heavens are split open and rain comes down, and earth is split open and plants grow out, and it fits with the verse. Because at the end of the verse it says وَجَعَلْنَا مِنَ الْمَاءِ كُلَّ شَيْءٍ حَيٍّ أَفَلَا يُؤْمِنُونَ. It's a possible interpretation, but the splitting then would be a metaphorical splitting, because the heavens don't actually split open when the rain comes down. There's another tafsir, which is that they were one thing. They were all joined together. The heavens, it's not that the heavens were joined together and the earth was joined together, but the heavens and the earth, everything was joined together. And this explanation is, it seems very likely, when in light of modern science, that this is what's being said here. And so this is a possible tafsir of the verse. And if you look at it, it's very nice, because it says don't. First of all, it says الَّذِينَ كَفَرُوا, and then it says don't they see? Don't they see? Now seeing can mean knowing as well. That's a possible ta'wil, but it doesn't say أَوَلَمْ يَعْلَمْ. It says أَوَلَمْ يَرَى, and the literal meaning of yara is actually, and it can be both. You can have a vision, physical sight, or you can have knowledge sight. Then it would be one of dhanna wa akhawatuha. But a common meaning is a physical sight, and that would be very nice meaning, that don't the disbelievers, because see that the heavens and the earth were all joined together and then we separated them. And this is exactly what I'm going to describe now, because you can actually see, based on observing light in the visible part of the electromagnetic spectrum, that the heavens and the earth, they were all joined together in the early period of the existence of the universe in the Big Bang model. The second verse is pretty conclusive. It says, وَالسَّمَاءَ بَنَيْنَاهَ بِأَيْدٍ وَإِنَّا لَمُوسِعُونَ. The heavens, we have made it with great power, and surely we are expanding it. So موسعون, it's an ism fa'il, and we say that ism fa'il حقيقة في الحال مجاز في الاستقبال. The literal meaning of an ism fa'il is the current time. And so this verse is literally saying that we are right now expanding the heavens. And this is, we're going to see this is what has been revealed by modern science. And what we found is that the speed with which this expansion is happening is increasing. The expansion of the universe is accelerating, and this violates fundamental laws of physics, because where is the energy coming from? Energy can't just come out of nowhere, and so they posit this thing called dark energy, and to make things fit. But it appears, if you put your materialist bias aside, it appears as though it's being made to expand faster and faster through some through something. It's like you just invent dark energy because to make things fit. But if you don't put that in, then it means that the universe is not a closed system. It's not a closed system. There's creation that's happening, and creation is happening. Space is being created at every moment. So this gives us. I find these verses very nice, and we the bringing science into tafsir is something that the mufassirun have always done. And that you see falak in the tafsir, they're referring to celestial spheres, and there's no hadith that proves that celestial spheres. We now need to inform our interpretation of the Quran through what we know about the universe, through the new falsafa. But that's just a side thing. Now we have this thing called the electromagnetic spectrum and the visible part of the electromagnetic spectrum. Another part of new falsafa is the belief that everything is made of atoms, and we have elements. This is the periodic table of elements, and we study this in chemistry. We need to know this well. We need to know protons, neutrons, electrons, the properties of the metals, the halogens, all of this. We need to be familiar with it in order to understand the new falsafa and talk about it in a way that conveys that we understand it and we can use it meaningfully in our theology. Now, we put these two things together. We have something called emission spectra. So emission spectrum. So we have the electromagnetic spectrum. The atoms and molecules. There are electrons, and these electrons around the atoms, they have shells, which have certain specific energy levels, and they can only occupy certain specific energy levels. So it's so when you can take an atom and excite it, and the electron, it goes up to an energy level, and then it comes back down to its old energy level. And when it comes back down, it releases energy, and the energy is the difference, the energy level between the higher shell and the lower shell, and you can detect as light in the visible spectrum, in the visible part of the electromagnetic spectrum. So in hydrogen, there's only one proton, one electron. So the spectrum is fairly simple. There aren't that many options about how the electron can go up or down, and so you get it releases energy that is that green light. So some green and some red light. Iron has far more electrons, and so there's many possibilities of how the electron can go into a different energy level and come down into an energy level. So you see all of these different lines, or actually lights, and you can. So how do we get these lights? Because it's not emitted in this way. It's actually emitted as a light. But Newton, he took the famous thing. You take a prism and you can break up the light into its constituent parts. So if you take the light that's coming out of hydrogen gas when it's excited, and it comes back down, and you split it open using a prism, then you see these lines. And if you do the same with iron, then you see these lines. And every element has emission spectra, and that are specific to that element. And these are like fingerprints with which you can identify an element. So you can take something, you put it into a gas chamber, and you excite it, and then you put the light that comes out through a prism, and you examine the spectral lines. You can tell which element it is. So these are called emission spectra. The light that is emitted. You can do the opposite as well. The opposite, you have something called the absorption spectra. The absorption spectra is the exact opposite, which means that if you shine a light through a gas chamber, which is hydrogen, then this light, as it goes through it, it will excite the electrons, and they will absorb certain particular wavelengths of light, which are the same wavelengths that they would emit if they were excited and then they came back down. So then if you take light and you shine it through a gas chamber, and then light comes out on the other side and you split it open with a prism, then you see black lines. And these black lines correspond exactly to the location where the colored lines would have been if you had done the opposite thing. So this is called the absorption spectrum. Now, what we can do is we can look at the sun or any star and run it through a prism and look at the light, and we see lines. We see lines. And we can see these lines, and we can match them to the emission spectra or the absorption spectra of the elements, and we can infer from this the elements that are present in the sun that is shining. And this is, subhanAllah, it's really amazing. It's really amazing. You can so all you're doing is looking at the light that's coming, and you can see the elements that it's made up of. So Edwin Hubble in 1920s, he first of all he discovered galaxies, because when you look, before people, they thought everything in the universe was a star, but then he said that there are certain objects that are not stars, but they're collections of millions of stars that are very far away. And so he observed stars, he observed galaxies that are very far away, and he did a spectral analysis of the light that came from the galaxies. And he found that he was able to find identify the elements, but he found that all of the elements, the spectral lines had shifted towards the red side of the spectrum. It's called redshift. In other words, it shifted slightly towards the right. In other words, another way of saying that is that the wavelength of the light had gotten longer. The wavelength of the light had gotten longer. And in modern astronomy, there's many methods for determining the distance of the stars. And this is also something to be that is worth learning. And it's not very difficult. So for close stars, you can measure. If you measure the location of the star when the Earth is on one side of the orbit, and the location of the star when it's on the other side of the orbit half a year later, and you measure the disparity in the distance and you measure the angle, you can figure out how far away it is. It's called the parallax. But you can only do this for closer stars. For further stars that are further away, there's other methods. There's certain stars that are called standard candles. These stars, they are constant. Their brightness is constant. We know how bright they are. And so since we know how bright they are, we measure their apparent brightness, and from that you can determine their distance. And there's other ways as well. There's a handful of ways. And so he observed the red shift from these galaxies, and he combined this by looking at their distance, and he found that the further away the galaxies were, the more red shift there was. And the way that this HUDs basically is that this means that these stars are actually moving away from us. And so since their light is coming towards us and the stars are moving away, and so if the light is coming towards us and at the same time the stars are moving away, that means that the wavelength of the light will increase slightly. And so the further away they are, the more the wavelength of the light will increase. This means the universe is expanding. So this was a revolutionary discovery. Then, and it's another point it's an important point in the HUDs of the Big Bang theory. We can also measure the relative abundance of elements. So there's one thing that I omitted here. I'll mention in a second. But we can mention the relative abundance of elements, which means that if you look at the stars, you can tell the elements that they're made of. So if the Big Bang theory was correct, then you move and everything was packed together in a small area, small volume, and it expanded at a particular rate, then in this time there are certain elements that would have been formed, and most of it would be hydrogen, and a large part would be helium, and a little bit of other elements. And you can work out, so that you can work out using mathematics, using models, that if the Big Bang theory were to be correct, then when we look in the universe, we should find that it's mostly hydrogen, some helium, and very little everything else. And they predicted it using the mathematics, and then they observed it and they found it was exactly the same. There's this thing called I don't have a slide on it, but there's an important thing called cosmic background microwave radiation. So that means that if the universe was very, very small at an early point in time, then it was very hot, and there was a lot of light. It was full of electromagnetic waves. This is the heat, this is the light. And then as it expanded, this light that was there, which was distributed throughout the universe, it expands with the universe. And as the universe expands, this light becomes distributed throughout the universe, and its wavelength increases. And so this is like a background temperature. Electromagnetic waves, they are energy. You can measure the temperature, and you can measure their wavelength. And this was discovered in the 1950s and 60s. There's this in the microwave frequency. Everywhere you look in the universe, there is this energy, and it's not coming from anywhere. It's not coming from a star. It's not coming from a galaxy. It's not coming from anywhere. It's just in space, throughout space, everywhere throughout space. There's this microwave radiation, and it's not coming from any source. And if you do the mathematics, then it is exactly the way that it should be if the Big Bang theory was correct. And so this was a very strong piece of confirming evidence. And there's many other confirmations. And so what they do is they build this model, and then another confirming evidence is that when you look at the night sky, the things that are further away, when you look at them, they're actually older. So if you're looking at something that's 1 billion light years away, then what you're seeing now is what happened 1 billion years ago. And if you're looking at something that's 10 billion light years away, you're looking at something that happened 10 billion years ago. So when you look at the sky, you're actually looking back in time. And this is another reason why that verse, it's so powerful. أَوَلَمْ يَرَ الَّذِينَ كَفَرُوا أَنَّ السَّمَاوَاتِ وَالْأَرْضَ كَانَتَا رَتْقًا. So don't they see? And so you're seeing back in time. You're looking back at the early universe. And when you look back in time, you see these things called quasars. Quasars are galaxies, and they have certain special characteristics. They emit a lot of energy, and they are spread all over the universe, but they're all far away. They aren't close together, and there's no quasars close to us. And so that seems to mean that in the early period of the universe's existence, the galaxies were different than they are now. And you can make a Big Bang model, and you observe all of these things, and you observe many galaxies, and you can now see, and you see that things that are further away are different than things that are closer, which means that in the past things used to be different, and you put it into the model, and you look at and you analyze it, and then you make predictions, and then those predictions are confirmed, and it's happened again and again and again and again. And so all of these confirmations, they lead to a very high degree of hadth knowledge, definitely close to yaqeen, if not yaqeen, that the Big Bang model is true. And this is not something, if you add this to the fact, add to this the fact that scientists don't want to believe that the universe began to exist in time. They want to believe in an infinite universe, because the fact that the universe began to exist in time has obvious implications that science can't explain everything. Because the universe began to exist, it means there's something outside of the universe that also exists. And that's where and so they don't want to believe in this. and then they tried all kinds of models, and steady state model, oscillating model, all of these, and the discoveries just don't match. They only work with a Big Bang model, and then the discovery that the universe is actually expanding faster and faster, it destroys everything that they want. So it's based on scientific evidence, and people often, they make, Muslims, they make a mistake. They say science doesn't give you certainty, and that's not true. We've learned science. There are certain things in science. There are certain scientific conclusions that don't give us certainty, but there are other scientific conclusions that do give us certainty. And one of the, so I mentioned the philosophy of science, but the philosophy of science is useful to read, but it ends up, it's also not useful, because it ends up taking you to the conclusion that you can't believe anything that scientists say, and that's just false. And this is not the way that the ulama generally look at science. Science is a source of knowledge, and revelation is also a source of knowledge, and the mind is also a source of knowledge, and we need to put everything into its proper place, and use everything where it works. And definitely, the Big Bang theory is, we have knowledge. We have knowledge that this is true, and this is how the universe began, and so this is something we need to know. It's the new falsafa. This is a brief overview, and I'll follow this inshallah with another lesson on how this discovery has affected arguments for the existence of God in our times. Sallallahu ala Sayyidina Muhammad wa ala alihi wa sahbihi wa sallam.